This is Pre-Calculus B, Unit 4, Polar Coordinates and Functions, Lesson 6, Rose Curves and Lemniscates. So we're going to look at two more classes of polar coordinate equations. Again, in Desmos, we can graph polar equations with the caveat that we need to be able to solve for r. Okay, so rose curves. Rose curves look like this. They look like r equals a times sine or cosine of b times theta. Okay, so, and I'm going to add sliders for a and b, and if a and b are both 1, we get a circle, right? And that's basically r equals sine theta, which is a graph that we've done before. In fact, we graphed that one by hand, right? But if I increase a, all I do is increase the size, right? So the multiplier outside basically multiplies the radius, causes the whole shape to grow. I'm going to leave it at 4 here. Okay. Now, as I change b, some interesting things happen. Okay. As I change b, it maps one circle with 1. When I do it to 2, it actually maps 4 circles, right? Or 4 loops. Okay, we call them petals. And this is where we get the idea of a rose curve, that it generates a flower-type pattern. Okay, when b is 3, we get 3. When b is 4, we get 8. When b is 5, we get 5. When b is 6, we get 12. Right? When b is 7, we get 7. And when b is 8, we get 16. Right? So what's the pattern? And what patterns do you notice? Well, hopefully you noticed right away that there's a difference between b being odd and even. Okay, when it's odd, like 1, I get 1 petal. 3, I get 3 petals. 5, I get 5 petals. 7, I get 7 petals. 9, I get 9 petals. 11, I get 11 petals, and so on. So b being odd tells you there's going to be that many loops, right? The other thing that I want to notice, and the lesson brings this out quite a bit about odd and even functions, and whether or not we can tell if it has symmetry with the x-axis, the vertical or the horizontal axis, or the vertical axis. I find all that interesting, and that's certainly worth looking at, but I find it easier to remember this. Sine, if I let b be 1, sine is vertical, right? And so look at all of these. This is symmetric with the y-axis. 2, symmetric with the y-axis. 3, symmetric with the y-axis. 4, symmetric with the y-axis. 5, symmetric with the y-axis. 6, symmetric with the y-axis. 7, symmetric with the y-axis. 8, symmetric with the y-axis. 9, symmetric with the y-axis. Okay. So we can tell that the symmetry is symmetric with the y-axis because we're using the sine function. What would happen, say, I'm going to leave it on 3, if I change sine to cosine? And really a lot of this can be resolved by doing this. And so we get the same 3 petals with cosine, it's just now it's symmetric with the x-axis. So cosine is symmetric with the x-axis, sine is symmetric with the y-axis. Another thing I find interesting is I change this to sine. Okay, it's upside down. You notice the loop that sits on the y-axis is upside down. Right? You know, what if I change this to a negative? What will happen? Well, it flips it right side up. Right? That's interesting to note. Okay. Also, now, what about odd? So, what if b is even, I should say? What if b is even? So, I'm going to leave it on sine and go 4. Notice for the even patterns, the number of petals is doubled. Notice also, for the even patterns, none of the petals is on either x or y axis. They're all evenly divided. 4, 6, 6. None of the petals is on an axis. 8, none of the petals is on an axis. 10, none of the petals is on an axis. And as such, by the way, it wouldn't matter if I change the sign. Change the sign, no change in the graph. Okay? So b being even always produces twice n the number. Right. These are called Rose curves. Now, another interesting fact, and then this isn't really brought out in the lesson much, but what if b is something other than an integer? What if it's like 1.5? And then we get overlapping petals, right? And there's some interesting things. 1.6, 1.6, 1.7, 1.8, 1.9, 2.1, 2.2, 2.3, 2.4. Okay, and part of the here is how far they map. They're going from 0 to 10 pi. And you'll notice some of these patterns seem incomplete, like this. Well, what if I go instead of from 0 to 12 pi? What if I go to 24 pi? Right, now it completes it. So it takes a number of times through to complete the cycle. I don't know if you guys have ever played with a kid's toy called Spirograph. So this is what this reminds me of, Spirograph. Now, a spirograph, of course, creates other interesting patterns. In this case, every function goes through the origin. Every petal goes through the origin. And so it would equate to a wheel spinning within a wheel whose diameter is the radius of the original circle. Okay. All right, so that's rose curves, which is flower petals, right? What if I do this? What if I say r squared equals a squared? Okay. Now, in this case, the Desmos doesn't know what to do because it has to be solved for r. So instead of r squared, I'm going to do much the same thing, but I'm going to put square root. A squared sine b theta. Okay, here we go. This is what's called a lemniscate. Okay, a lemniscate. And it's a kind of an infinity sign, and it creates the lemniscate they have you graph in the lesson is for b equals 2. You notice there's 2 petals. But you can actually change this. What if b equals 3? Notice there's now 3 petals. B equals 4, there's 4 petals, 5 petals, 6 petals, 7 petals, 8 petals. Okay, sine is notice it's not very nice as far as being symmetric here. Okay, but for the sake of simplicity, what you're going to be tested on is the case where b equals 2. So r squared equals a squared sine 2 theta. That creates the lemniscate. Now, if it's sine, notice the diagonal relationship. If I say negative, try that again, negative, okay, or put a negative on in here, it flips it across the y-axis or the x-axis, whichever you think of. But it gives it a negative slope, Whereas if I change it to cosine, it sets up a horizontal. And if I say negative on the whole thing, it sets it up vertical. So a lot of your questions are, given a graph, predict which function creates that graph, and or start with the function and create the graph, right? Either way. All right. So recognizing classes of functions. So lemniscate, that's where r squared equals a squared cosine 2 theta, and rose curves, which is r equals a cosine, right? And when b is even, then there's twice as many petals. When b is odd, there are b petals. B petals. It sounds like, hey. All right. So hopefully that helps you play with Desmos. Kind of map out the patterns here and see if you can recognize any other patterns.